resolution
apply the principle of resolution
of forces
to
find the
unknown force P
P
in magnitude
in magnitude
and direction in this
system
system of force. Now, this is how it works. It's very simple, right? The idea is simple. You are giving this you are giving this system of force, right? You are told to solve this guy. Meaning, what will be the value of P? The question says that find the magnitude of P and the direction, right? When we said this topic is actually under equilibrium, right? And the word equilibrium, what does the word equilibrium mean? A state of balance. Meaning, in this case now, we are considering vertical force and horizontal force. What it means is that all your forces, vertical force, the forces acting upward must be equal to the what? Forces acting downward. Similarly, if it is horizontal force, the forces of this nature must be equal to this force, right? So what this question is saying is that for this system of force to be in equilibrium, what will be the value of this P? Given a question, you can't just assume that P is 35 kilonewton. You are wrong. We can't just assume that P is 50 kilonewton. We are wrong, right? So that's why we need to solve. You solving, you know the specific value of P, right? That specific value of P, by the time you substitute it here and do your calculation, you get 0. And that's the idea of equilibrium, a state of balance. Meaning the net force acting upward must be equal to what? Net force acting downward. Now, by equilibrium, we have 3 conditions to be applied, right? Now, what are these conditions of equilibrium? First thing first, your conditions of equilibrium, right? And they are just 3. Summation f of y equals 0, summation f of x equals 0, and summation of moment about any point equals 0. Summation of moment about any point equals 0, right? But for this question, let's say this is the first condition, this is the second condition, and this is the third condition. For this question, we'll be applying the first and second condition. What did I say? We'll be applying the first and the second condition. Here's what you should take note. For the first one, summation f of y, force of this nature positive, force of this nature negative. Summation f of x, force of this nature positive, force of this nature negative. And where this idea is coming from is your Cartesian coordinate. Your Cartesian coordinate that you know. Recall, from your Cartesian coordinate, you have your x and your y axis, right? This is the positive region. This is the positive region, negative region. From this Cartesian coordinate, this one x axis, let's do something like this, and we have this. From here, you can relate what we've stated here to this, true or false. It is from our Cartesian coordinate we brought out this. So what it means in general is that considering these forces related to your Cartesian coordinates, and by your Cartesian coordinates, it means force of this nature positive, force of this nature negative, force of this nature positive, force of this nature negative, right? Now, check this force system, identify how many force of this. Okay, let's apply the first one. Summation f of y equals to 0, right? Now, we want to apply the first one, which is summation f of y equals to 0 to this force system. Come back to this force system. Identify how many force of this nature do you have? Mind you, we have an inclined force here, right? Consider your inclined force in both cases. For case 1, you want to consider this guy, right? Consider your inclined force under this guy. Similarly, for case 2, consider your inclined force under this guy. Are you getting my point? Now, let me ask my question again. We are given this force system. You already know that the task is identify what? Vertical forces. You are considering the given vertical forces. From this question, this is a vertical force, purely a vertical force. This is a vertical force. This is also we don't have any vertical force. Let's say this place, let's say we have L here, right? L kilonewton. Meaning, considering summation of f of y, I have a purely vertical force, which is what? L kilonewton. So I'm not saying that if you are considering this guy, from the question, consider the given direct vertical force and all the inclined forces. But in this case, we don't have vertical force, meaning you're only considering all the inclined forces. Now, identify how many inclined forces do you have in general? There are three. This first one, which is what? 35 kilonewton. This second one, 20 kilonewton. And this third one, P kilonewton. So what it means is that considering this guy, you are using these three forces that you identify. But this is how it works. Since you say that summation f of y equals to 0, meaning all these forces, they are traveling to the y-axis. You know, this is your y-axis and this is your x-axis. This is the positive y, this is negative y, positive x, negative x. You considering this guy, it means those inclined forces, they are traveling towards the vertical axis. Now, this 35 kilonewton, it is going to the vertical axis, right? In what direction is it going to go? Positive. How do you know it is positive? Just imagine that you are taking the tip of this 35 kilonewton. By the time you take the tip, you already know that you are going to the vertical axis, right? Meaning you are going like this. On getting to the vertical axis, what region of the vertical axis? Is it the positive or negative? Positive. Meaning you have positive 35, right? Now, consider the sign. Will it take sine 35 or cos 35? It will take cos. Anything that we'll be learning here, that's what we'll implement here, right? Now, say you have this inclined force, P kilonewton. Say this is 1. For 2, same thing. Say you have this inclined force. This is x. This is y. Say this is P. Now, let's say your angle for case 1, your angle is inclined here. Call this theta. For case 2, your angle is inclined here. Call this theta also. Now, what I want you to do for me, check case 1. Where is your angle inclined to? Is it the horizontal or the vertical? Horizontal. Now, check case 2. Is it inclined to the horizontal or vertical? Vertical. You know, for this case 1 inclined to the horizontal, you get f of y and you get what? F of x. True or false? True. Same thing, you get f of x and you get what? F of y. Now, let's see you solve f of x and f of y here. And we are also going to solve f of x and f of y here. Then we compare our answer. From that answer, we are going to deduce a statement. Meaning, generally, anything that will be observing here, that's what we apply here. Now, let's see how it works. F of y in this case will be what? F of y in this case, meaning the same idea, meaning that in this case you have P kilonewton, right? Since you are considering f of y, it means P is traveling towards the y-axis. On getting to the y-axis, is it the positive region or the negative region? Positive region, right? Now let's say P. Now this angle is either it take cos or it takes sine. But observe, this angle, where is it inclined to? Horizontal. It is inclined to the horizontal. Horizontal take cos. Vertical takes what? Sine. Meaning for this guy, I have what? Is it P sine theta or P cos theta? P sine theta. That's it. Why is it P sine theta? Because the given angle is inclined to the what? Horizontal. Meaning wherever your angle is inclined to, we take cos. Then the other side take sine. That's what we are saying. Now for this guy, I have what? P sine theta. F of x here. This becomes what? P cos theta. Now let's solve for this guy too. F of y here is what? P cos theta. Then f of x here is what? P sine theta. Now compare case 1 and case 2. What's the observation? Is it correlating to what I've stated? To what I've said? It is correlating, right? Meaning, so what you are saying is that generally solving resolution of force, giving a question under resolution of force, this becomes the idea. Nothing is changing. And this idea is that anywhere your force is inclined to take what? Cos. Automatically, the other side take what? Sine. And that's what we implemented here. Because our angle here is inclined to the horizontal. Horizontal takes what? Cos. Vertical takes what? Sine. Same idea. Our angle is inclined to the what? Vertical. Vertical takes what? Cos. Horizontal takes what? Sine. Now, apply the same idea here. It becomes what? Now let's start with, we have three force system. We have three forces rather, 35, 20, and P. You might start with anyone. So which one should we start with? 35, right? You know how it works. 35 is going to the y-axis. On getting to the y-axis, is it the positive or negative? Positive, meaning you have positive 35, right? Positive 35. You know where positive 35 is coming. Now the question is, the angle involved is 35 degree, right? Is it going to take cos 35 degree or sin 35 degree? Cos 35 degree. The question is why? Why? Because 35 is inclined to the what? Vertical. So it takes what? You are just applying same idea here. So you have 35 cos 35 degree. Moving on. Are we considering this 20 kilonewton or 15 kilonewton? Which one should we go with? Let's go with 20, right? Yes. The same way you solve this guy. So 20 becomes what? You are tipping it to the vertical axis, right? Yes. On getting to the vertical axis, is it positive or negative? Negative. So what do you have? Minus 20 sine or cos? Cos. Why is it cos? Because it is inclined to the vertical. So you have minus 20 cos 15 degree. Minus 20 cos 15 degree. Is that all? No. No. It should mean we are left with this guy, right? Which is P. Yes. Now, P going to the vertical axis. That would be what? Negative P or positive P? Negative P. So you have negative P. Is it sine theta or cos theta? Sine theta. Because in this case, the angle is inclined to the what? Horizontal. Meaning horizontal take cos, while vertical takes sine. So you have what? P sine theta degree equals to 0. And by condition 1, summation of all vertical forces must be equals to what? 0. And that's what we've done here. Alright, from here, the next thing to do is to make P sine theta the subject of the formula. Right? Given the question, we have to calculate P and we have to calculate theta, which are the unknowns. From equation 1, the idea is that make P and theta the subject of the formula. Then this is the relationship. Meaning P sine theta becomes your subject of the formula. You are making P sine theta the subject of the formula. Similarly, for equation 2, how do you get equation 2? Applying this guy, you make P cos theta the subject of the formula. But let's see how it works. Now, from here, the value of this, what's the value of this? 35 cos 35, what do you have? 28.67. 35 cos 35, you have 28.67 minus 20 cos 15. What is the answer? 19.319 equals to P sine theta is going to the other side, meaning positive P sine theta, right? Yeah. Now the subtraction of this will give you what? 9.35. Therefore, P sine theta is equals to 9.35 kilonewton. Call this equation 1. Now we've gotten equation 1. How do we get equation 2? Applying this guy. And this condition says that summation of f of x equals to 0. Considering this law, any force of this nature positive, any force of this nature negative, right? The same way you solve for vertical forces, that's what you are reversing here. Now this force system, check this force system. You are making use of your inclined forces, right? How many inclined forces do you have here? 3. You have 3 inclined forces, and you have this horizontal force. Now what this means is that you are considering all the inclined force and this horizontal force. Nothing is changing, same idea. The way you solve for y-axis, that's the way you are going to solve for what? X-axis. Now, which one are we starting with first? 35. Starting with 35, what it means is that imagine you are taking the tip of this 35 to the x-axis, right? On getting to the x-axis, is it in the positive region of x or the negative region of x? Positive. So it becomes what? Positive 35. Now, will it take sine 35 or cos 35? Sine 35. Why is it sine 35? The idea is that anywhere your angle is inclined to, take cos, while the other side takes what? Sine. So in this case, our angle is inclined to the vertical, meaning horizontal takes what? Sine. So you are saying 35 Sine what? 35 degree. Then the next one is what? Which force should we consider next? P, right? Applying same idea to P, it becomes what? It becomes positive P cos theta. Next up, what do we have? This 20, right?
Negative
That becomes what? Negative 20, meaning this guy is going to this side. It becomes negative 20. Sine or cos? So you have sine 15 degree. Then don't forget that you have this guy here, meaning negative 100. So you have negative 100 is equals to 0. 35 sine 35, what's your answer?
20.075.
20.075 minus 20 sine 15, what's the answer?
5.176.
5.176 minus 100 is equals to negative P cos theta. Because you are making P cos theta the solution of the formula. By the time P cos theta go to the other side, it turns to what? Negative. Now, what is the summation of this guy? What do you have?
5 minus 85.
Minus
85.
85.101 is equals to what? Negative P cos theta. Observe, negative cancel negative. Meaning from here, you have P cos theta is equals to what? 85 kilonewton. Call this equation 2. Approximately, you have 85 kilonewton. So call this what? Equation 2. Now, how do we get P and this theta? Using equation 1 and equation 2, you get these guys that you are looking for, which is what? P and what? Theta. Now, we call your trigonometry, that's what we'll be using here, trig identities. From trig identity, we have that sine square theta plus cos square theta is equals to what? 1, right? Then we also have tan theta is equals to what? Sin theta over cos theta. Call this 1, call this 2. So we are using, either we make use of 1 or 2, we still get the same thing. Now let's use the first one, meaning sin square theta plus cos square theta is equals to 1. So what it means is that combine, bring your equation 1. What's your equation 1 here?
P sin theta.
P sin theta is equals to what? 9.35. Then equation 2 is what? P cos theta is equals to what? 85. Now what you should do from here, square both sides, square root both sides. Now up to this guy, from equation 1, we want to make use of number 1 trig identity. And from number 1 trig identity, what it means is that sin square theta plus cos square theta is equals to 1, right? Now check, from equation 1, I'm having what? Sin theta. Meaning, I'm having sin theta, but I need what? Sin square theta. So sin square theta, how do I get it? Meaning that I'm going to square this theta. But mind you, it's going to affect the left hand side and the what? Right hand side. So that your answer at the end, it will be equivalent. You get the point? Now, from this equation 1, what it means is that square root the left hand side, take square to the left hand side and take square to the right hand side. Similarly, for equation 2, take square to the left hand side and take square to the right hand side. Now, by doing that, this becomes what? From equation 1, taking square to both sides, meaning we have P square sin square theta is equals to what? 9.35. Call this equation 3. Call this what? Equation 3. Now, for equation 2, same idea. What do we have? P square cos square theta. Let's do this together. What do you have? P square cos square theta is equals to what? 85 square. Call this equation 4. Now the next step is add equation 3 and equation 4. Add equation 3 and equation 4. But before adding, let's get the magnitude. 9.35 square is what?
87.4.
9.35 square. 80 what?
7.425.
So in place of this, let's put 87.423. Then 85 square is what?
7225.
7225. Is that all?
Yeah.
So meaning, you know how we got 87.423, right?
Yeah.
And you know how we got 7225. So now from here, add equation 3 and equation 4. Meaning that p square sine square theta plus p square cos square theta is equals to 87.423 plus what? 7225. Now, from this left hand side, observe, I can, what's common here?
P square.
P square. So factorize p square. You have p square all into brackets cos square theta plus sine square theta. The summation of this guy, what do you have?
7.
What's the answer? Is equals to 7312.423. Now, from here we've gotten this, right? This is where the idea of trig identity comes in. By the first trig identity, what do we have? Sine square theta plus cos square theta is equals to 1. Meaning, anywhere I see sine square theta plus cos square theta, what am I going to substitute? 1. But before then, we can call this equation 5. We can write equation 5 as p square all into brackets sine square theta plus cos square theta is equals to 7312.423. That is p square multiplied by 1. You know where 1 is coming from?
Yes, sir.
Equals to 7312.423. Now I have p square is equals to 7312.423. The question given was what? What are we asked to calculate?
Find P.
Find p. Now up to this level, how do I get p?
Square root.
Square root both sides. Square root the left hand side and square root the right hand side. So it becomes square root of p square is equals to square root of 7312.423. Then of course you have p is equals to 85.51 kilonewton. Approximately, what do you have? 86 kilonewton. Meaning that for this system to be in equilibrium, the value of p must be what? 86 kilonewton. The value of p must be what? 86 kilonewton. That's just the first question. The second question is what? Calculate the direction, meaning calculate theta.
Yeah.
We've gotten the value of p, right? We got the value of p to be 85.61 kilonewton. We are yet to know our angle. Then we call from equation 1, we have p sine theta is equals to what? 99.35. Then equation 2, p cos theta is equals to 85.101. This is equation 2. This is equation 1, equation 2. Now, to get your angle, you can make use of either equation 1 or equation 2, right? Now, using equation 1, we then have that p sine theta, which is equals to 9.35. It implies, make sine theta the subject of the formula, meaning sine theta is equals to 9.35 divided by p. What is the value of p? 85.61. So what's the answer?
6.
The ratio of this, what's the answer? The ratio of this is what?
0.1.
0.10992. Therefore, theta is equals to sine inverse of 0.1092. And from here, what's your theta? What do you get?
0.
Theta, sine inverse of this, what do you have?
6.27.
6.27 degree. We got 6.27 degree using what? Equation 1. Now let's use equation 2. Meaning same idea, right? Now let's do this together. This will be what? Cos theta is equals to what?
Cos theta is equal to
85.101 divided by the value of P, 85.61. Now divide, what do you have? Cos theta is equals to 0.9941. Therefore, theta is equals to cos inverse of 0.9941. What's the answer?
The answer is 6.25.
From here, theta is equals to 6.25 degree. When we use equation 1, we got theta to be what? 6.27. When we use equation 2, we got theta to be what? 6.25. Approximately, theta is equals to 6, right? Or you say 6.3. So what it means in general is that, let's approximate, saying theta is equals to 6.3 degree. Meaning, for this guy to be in a state of equilibrium, the angle, the value of the angle is what? 6.3 degree, and the value of P is equals to what? 85.61 kilonewton. So you've answered that question. So this is how you answer question on force system. So the same way, you know what we did here now, we found P and theta using the first trig identity. You can also find P and theta using the second trig identity. You definitely get the same thing. But in this case, we added equation 1 and equation 2. We added the left hand side and the right hand side after squaring it. But for that one, you are going to divide. You divide the left hand side and divide the right hand side. Then from there, make theta the subject of the formula. So that's how it works. Meaning, for the second one, you are going to get theta first, right? By the time you get theta, you are going to substitute into equation 1 or equation 2 to get P. So that's it.